Okay, I'm going to give you a quick overview of vectors. The definition of a vector. A vector is simply a quantity that has both size or magnitude and direction. So I'll give you an example here on this graphed paper where I have a point A and it goes to a point B. Now I'll draw a line from A to B to represent the vector. Alright, and the vector goes from point A to B, so the direction is that direction. And let's call it a size or magnitude A. Alright, so we can write this vector as A with a line under it, or A with a squiggly line under it, or what you're going to see more often is going to be A, B with an arrow pointing direction from which it goes. So it goes from A to B, that's what it tells you. The line is drawn from A to B, the direction is from A to B. Alright? We can also draw this line and we can have it coming from B to A. So let's start here at B, and then it goes to a point A, and let's say it has the same size or magnitude, and it goes a different direction because it's going from A, it's going from B to A. We can call this the magnitude is A, or the size is A, and therefore it's going in the opposite direction, so we're going to put a negative sign. Alright, so it's the same size line going in a different direction. Alright, so instead of going from point A to point B, it's going from point B to point A. So that will be represented by BA. Alright, and the reason we get this negative sign is if we remember our axes for our graph, we get on the left hand side is a negative, and to the bottom is also a negative, and to the right hand side is a positive, and to the top is a positive. So the first one goes in upwards direction, so that's in a positive direction, and the next one goes in a downwards direction, which is a negative direction. So although the magnitudes are of the same size, the direction differs, and the direction is denoted by the sign, which is a negative, telling you it's going in a negative direction. Alright, now we can also add vectors, and I'm going to give you an example here where we're going to do a resultant. So let's see if I can put up a diagram for you. Alright, so this diagram here, I started labeling it, but something went wrong in the transformation, so let's put it here, and this is going to be C, and this is B, and we have the vector U, and we have the vector V. So here we can write that A B, the vector AB is equals to U, and the vector BC is equals to V. Alright, and we want to find the resultant of the line. Now in this case we're going to write the terms in relation to U and V. So in the example we're going to say that write in terms of U and V. Alright, now let's give some questions to do in here. So let's come up with some questions. So let's say you're going to try to find the vector AD. So question A is find AD, and it's in terms of U and V. And we're going to find for B, we're going to find let's see, CD. And for C, we're going to find, let's say, AC, the vector AC. So let's start with AD. Now in a parallelogram, these two sides are the same, and since we're going from A to D and we went from B to C, that means they're going in the same direction and they have the same magnitude. So then therefore your answer for the vector AD is going to be equals to v, because it's going in the same direction, so it's not going to be opposite. We have a negative sign, and because the sign is a parallelogram, we know that this side is equals to this side. All right, so that means that the size is the same. Okay, now for question B, we have CD. Now this line is equal in magnitude or size to that line. However, we went from A to B. We went in the direction going this way. Now we said we're going from C to D, so that means we're going in the opposite direction. We're going that way. So the sizes are the same, but the direction has changed. And we said if it goes to the left, it's going to be a negative. So although that they're the same magnitude, they're going in different directions. So then CD is going to be equals to negative U. All right. And for the last one, we have C. We have the resultant. Now this is going from A to C, so the resultant is usually denoted by a double arrow. All right. And in this case, we're going to add the two vectors, all right, to get what this is. So here we have AC is equals to, and we're going to add B. So we're going to add AB plus BC, and we know that in U and V, AB is equals to U and BC is equals to V. So that is your answer for the vector AC. AC is equals to U plus V, because we're going to represent it in terms of U and V and not in terms of BC or CB. All right, and that's your answer, and that's simply adding vectors.